automated meter reading, monitoring and capturing of real-time smart meter data from the remote end of all renewable energy sources like solar, wind in Tamil Nadu for online billing and forecasting. Now he'll be delivering his speech and sharing his experience in renewable energy integration issues and opportunities with the Tamil Nadu Electricity Board. Over to Mr. Balaguru Raja.
Thank you, madam. Thank you, one and all, for giving this wonderful opportunity. Students from the participant from various colleges. So thank you all for this wonderful opportunity. So we'll start with this. Okay. So renewable energy. So what is renewable energy? So first we have to, before that, what is energy we have to know. So what is energy? So energy is, you know, that it's the ability to do the work, and that work is transfer of energy from one form to another form. So we have different forms of energy, like chemical energy or mechanical energy, electrical energy. So if you take a battery also, it's a conversion of chemical energy to electrical energy. So like the different forms of energy. So conversion of energy from one form to another form is called as a energy. So that is the basic thing. So because before moving on to the renewable energy, so what is energy? So if you take a wind energy, so what is this wind energy? So the wind, we are getting the wind. So wind energy, so that the kinetic energy is converted to the mechanical energy is converted to the electrical. So how these things are happening? Got it? So the kinetic energy and the mechanical energy. So by means of the wind turbine, the wind is, we are getting the wind, that wind is converted in the mechanical energy. So the kinetic energy is converted to the mechanical energy, then to the electrical energy. So one form to another form is called as a basically energy. So energy is the transferring one form to another form is called as energy. Okay. Now, what are all the types of energies? So we'll see that. So there are two types of one minute. I'll zoom this. Okay, there are two types of energy. So one is renewable energy, another one is non-renewable energy. Okay. So you know that renewable energy. So this topic, what we are talking about is renewable energy. So in the renewable energy, what all the energy sources are there in renewable is solar, wind, hydroelectricity, and biomass. So these are all the major renewable energy what we are using today. Okay. So solar, wind, hydropower, and biomass. So this is renewable energy. This renewable energy is otherwise called as non-conventional energy, or it's otherwise called as infirm power. Why infirm power? Because the power firm means strong, you know that. So infirm. So this is not firm. So solar we are getting, suddenly when the cloud passes, what happens? You won't get the power. Wind, suddenly the wind is blowing. Sometimes the wind will be minimized. So this is called as the infirm power. Okay. Similarly, so this is infirm power or renewable power, or it's a non-conventional energy. You got it? Next, on the other hand, you can see in the energy resources, this is limited. That fuel is limited. This is called as a non-renewable. What are the non-renewable sources? Say here we are given coal, oil, gas. So these are all the non-renewable sources, or otherwise called as conventional sources, or otherwise called as firm power. So got it? So This is conventional, non-renewable, firm power. Firm power is this one. Other hand, what we have is non-conventional, renewable, infirm power. So this is solar, wind, and all comes under here. So the non-conventional, we have coal, oil, gas. So because why this is firm power is coal availabilities. We have a very good source of energy is coal, because most of the energy production in India all over the world is mainly depends upon the coal, and most of the shares of power is through coal only, because which will give you constant power. So like a wind and all, it is variable. So the integration in the grid, that and all is very difficult in case of a renewable energy. So however, we have a technologies, we are adapting the technologies, that and all is different. But however, this coal, oil, or a gas is very important and very easy to integrate with the power grid. Okay, so that is the two types of energies, renewable energy and non-renewable energy. Okay, so next we'll go. So you can see the sources of energy, renewable and non-renewable. So renewable is you have solar, wind, biomass, and water. Water is from your hydropower, and geothermal, wave energy, wave. So today we have a tidal power and all. So wave concept is another technology. We have all these things from the natural resources. Renew means a new. So renew means, see, you, what is renew? You take that word renew. Newly, it will be the power. The wind is comes now. Again, the next time the wind is not the same wind. It will be different. The solar is coming here. Again, the solar is different solar. So the solar insulation is different. So the wind power, wind speed is different. Every time you're not getting the constant. So renew, new power. And from the source is easily available is renewable energy. And from the waste we are like a biomass and all, from the waste product, the byproduct, we are using this as a, we are producing the power. It's called as a renewable power. So from the biomass also we can get this renewable energy. Okay. So this renewable. So non-renewable is coal. Coal means the coal, lignite coal, bituminous coal, anthracite coal, like that we have studied like that. So this coal, like a lignite coal or a bituminous, semi-bituminous coal, with that we are producing the power. So particularly from the thermal, that is the thermal power station. Okay. So that is coal-fired power station. These all normally what we call this non-renewable energy is fossil fuels. So fossil fuels is your gas, your oil, coal. So from this fossil fuels, we are getting the power. Another one is uranium. So from the uranium, thorium, plutonium, you have the fuels. So these are all the fuels, With the uranium, we are getting the nuclear power. So that is comes under a non-renewable energy. So you have a Kalpakam. In Tamil Nadu, we have a Kalpakam nuclear power station. So there and all, they are producing the nuclear power. And coal, thermal power station we have in North Chennai thermal power station in Tamil Nadu, in Chennai we have a North Chennai thermal power station. So this is non-renewable. We have a Mettur, Tuticorin. Okay, so these are all some of the coal-fired power station, and a natural gas substation, basin bridge, like that we have a gas producing power station. So these are all the sources of energy. So we have two classification, majorly renewable and non-renewable. Okay. Now, why we go for this renewable energy today? So that is the question. Okay. So today, the global warming. So what is global warming? Dr. Abdul Kalam always talking about this particular, he talked about many things in global warming, particularly, the Jatropha seeds. Jatropha seeds, the Pungan, the Pungan Maram. So in Tamil, we'll say that Punga Maram. So that seed also, the waste seeds from the trees, from the seeds we can produce the bio oil. So what are all the waste products that and all we have to reuse and reutilize, so to bring the electricity, or not only electricity, that's what I said. See, you can use as a gas, gobar gas, like see in a biomass, you can by fermentation it gets into a gas, so it converts into gas. That gas is converted to a electricity. So instead of going for the electricity, you can directly use it for the cooking gases. So that means, which means that what is that is, I said earlier, energy is transferring of one form to another form. Directly going for the electricity alone is not an energy. Even if you're taking as a gas also, that is also an energy. Clear? So we have to utilize the gases. So that's why I'm saying this one's global warming. So we have to protect the earth. So protect the earth is very, very important. So today, by what to do is, at least we have to plant the trees. That what I can do is, at least we can plant the trees. Save the power at the consumer end. How you will save the power? Say for example, when you are using a filament bulb in some of the bathroom lights or in the outdoor corridor and all, instead of that, the students, you might have changed that all those things to LED lamps. So we are able to do, that we can do. Okay, we will think in a different way, not in a thinking about in a different way, not like that. Very simple. As a student, what we'll do? Okay, we have a this filament bulb. At least after the end of the session, what you have to do is, this is my request. So if you have a filament bulb in your bathrooms or in your corridors, at least you change that filament bulb, 40 watts bulb or 60 watts bulb. You remove that bulb and you replace that by LED bulb at least. So that's what you have to do. So this is the small contribution by the students in terms of with respect to the global warming. Okay, okay. So this is what. Okay, then greenhouse effect and global warming, ozone layer destruction. And you know this ozone layer destruction, you might have seen this, ozone layer, there's a hole like this, that, but this during this COVID period also, this you might have studied, this ozone layer is minimized, which means that the pollution is minimized during the COVID period, because the transportation is minimized, the factories and all shut down, industries shut down, lot of commercial industries are shut down. So the what is that emissions, the greenhouse gases emission is reduced considerably. So in that cases, the ozone layer is protected now this period, that is COVID period. I'm talking about this, what we're talking about, this corona or COVID period. So this is one of the advantage, that may even the pollution index also, that is the main thing, the pollution index also considerably reduced during this COVID period, because of a shutdown of many industries, commercial industries, business, everywhere. All vehicles stopped. Most of the vehicles were stopped during the COVID period, during March end and April and all. It's a very big lockdown. Okay, during that time and all, it is considerably reduced. And acid rain formation, radiation, and health. So these are all the environmental issues is what we are facing today. However, we have to slowly overcome this one. So if at all, if not overcome, so at least the contribution, each and every citizen should do the contribution regarding this global warming. Okay, so you can see this. See what is here, the global is because of the greenhouse effect. Okay, the heat energy get trapped inside the globe. So the globe, we are in the like in the houses. So the gases emitting from the industries, this and all, this get trapped inside. We are inside. Say for example, in a house during the summer, what happens? The heat wave is get inside and get trapped, and the temperature is increased. So this is what we are in the houses and all you can see. Similarly, the globe is also my house. In that house, the temperature is increasing day by day. Now the temperature is increased in a century. In this 100 years, it has increased to 1 degree Celsius. So that is the thing, nearly 1 degree. So we are in the situation like that because of mainly due to the pollution, because of the pollution. So from the industries, the pollution, the greenhouse gases are emitting. Because of that, the pollution and the climate change also. Climate change, normally we are getting the monsoon also, it's changing. The southwest monsoon or a northeast monsoon particularly, it's changing. It is not during the same period. So due to that, we are the globe is heating every day. Even in India, we are facing this. So these are all the greenhouse gases. You can see this uh, from the, say for example, in the thermal power station or chemical industries, fertilizer industries, or even from the car. The nitrous oxide is emits in a car. So these gases called carbon dioxide, or a sulfur and a nitrous oxide, sulfur oxide. These are all the gases which emits from the fertilizer plant, from the industries, thermal plant like this. So we have to reduce. So see, you can see this table. In this table, the coal, oil, diesel, natural gas, what we said earlier, these are all the conventional plants where you can see the carbon emission is very high and sulfur is high, nitrous is high. So we have to protect the earth. So that's what the government has framed, the target for renewable energy particularly. So you can see the renewable energy. If you see hydro, the large hydro, small hydro, wind, PV solar, solar thermal, biomass, geothermal. So we have a lot of renewable energy. So this renewable energy contribution is very important at this particular stage to reduce this greenhouse gases. So that's what the greenhouse gases emissions should be. It's reduced due to this contribution of your renewable energy. Okay. So it is evident from the table that the renewable energy sources make little contribution to CO2. So that's what I said is the renewable energy which has a less contribution of greenhouse gases. So that's what we are moving to the greenhouse. That's what we are contributing to the renewable energy. So not only this, the government of India has framed, has fixed the target for this renewable energy for 175 gigawatt by the year 2022. So that means in 2000, before 2022, up to the year 2022, we have to reach the target of 175 gigawatt. So giga is, what is the mega, kilo, mega, giga, 10 power 9. So that much of 175 gigawatt power is only from the renewable energy. So like a wind, solar, only from the renewable energy, because the contribution should be there to avoid these greenhouse gases. Okay. Now see this car. What happens is the nitrous oxide is emitting, and you can see this factories like a chemical industry or thermal power plant like this. So this gases emissions takes place here. So SOx, NOx, carbon, all those things. So this becomes a primary pollutant, and this is another secondary pollutant, which is nothing but a acid. So primary pollutant is called as a wet deposition, and the secondary pollutant is called as a primary pollutant is a dry deposition, and this is your wet deposition, which turns into an acid. So we have two types of deposition: dry deposition and wet deposition. So you can see this effect of the acid rain. So I said earlier, here this is your dry deposition and this is your wet deposition. So when the wet deposition takes place, you will get a acid rain. So what happens ultimately? Everyone's contribution to save the earth. So the earth itself, yeah, so already lot of issues we are facing. So this we should not face in future, which means that everyone should contribute to the earth, particularly in the global warming. Okay, so this is the effect of the acid rain. This is mainly due to the wet deposition. Whereas in case of a dry deposition, what happens is this dry deposition will produce the heat, will produce the heat in the globe. But wet deposition is severe to that. This leads to the acid rain. So this gets chemical reaction takes place and leads to the acid rain. So this is very, very dangerous. So imagine that the rain is acid. So how the human, so see the tree, how it has happened. So this is the effect of a acid rain. So very, very important. So we all got it. So this is primary pollutants is dry deposition is creates the what we are suffering now and all. It's a dry deposition. It's a heat inside in the globe. It's get trapped inside. So this greenhouses gases get trapped inside, and the temperatures increase. So this is called as a global warming. And primary pollutant is dangerous, which is nothing but acid H2, HNO3, so H2SO4, so sulfuric acid, all those things will create. So this is danger, which is the effects due to acid rain. Okay, so this is the major thing. So why we go for a renewable energy. So we should. So the European countries. So the European countries, you can see nuclear power, thermal power like that. They are the major contributor of nuclear and thermal in around some 15 years back. And now you can see this is. So now they have the totally most of them they are moved on to renewable. This is what we have. Okay, solar. So very well, solar energy. So we have a abundant of solar power. Say uh, out of 365 days, okay, in a year, 300 days we will get the solar power in India. Particularly, I'm talking about India. In some other countries it's different, but when India is blessed by that much of solar installation, solar potential is very high in India, we all know. So we are so when the southwest monsoon and northeast monsoon only we are getting rain. Okay, other than that, most of the days, that's what, 300 days out of 365, 300 days we are getting a clear sunny days. So this energy, this energy is abundantly available, and now the project is lot of projects from the solar energy we are getting. So this solar is very, very important. It's the growth of solar is enormous. The growth of solar is growing very fastly in the recent decade, particularly in the recent years, in this decade. So you see, this is solar, the panels from the PV cells. We are getting the power. So the radiation, what is how we are getting the solar is because of the sunlight. So sunlight is, you have a radiation, so solar radiation. So there are two types basically: direct sunlight and diffuse sunlight. So direct sunlight is directly uh, from the sun to the surface. So this is called direct beam, direct sunlight.
Diffuse sunlight means the sunlight which falls on the light, which got yellowish line of sight. So which falls on the mountains, which falls on the buildings, which falls on the trees, and then we are getting that solar energy. It's called as a diffuse sunlight. So what is the difference between this direct and diffuse sunlight is the radiation, solar radiation, what we are getting in direct, which is efficiency will be very high. Whereas in case of diffused sunlight, the efficiency of the PV panel is low when compared to the direct beam. For particularly the high insolation area in India is Kashmir, Ladakh area, Ladakh, Gargil site and all, where we have a very good solar potential and the radiation is very good. Why? The solar direct beam is more in Kashmir. Whereas in case of Tamil Nadu is also having high solar radiation. Rajasthan we also having solar radiation. But what is the comparison between Ladakh and Tamil Nadu? Tamil Nadu is you have a different that is diffused sunlight. Whereas in case of Ladakh and all, you have a direct sunlight is more, which means that, for example, when you're cooking a solar cooker in Ladakh area, the same thing if you're cooking in Tamil Nadu, so you can cook it in half an hour. Say, for example, half an hour you are cooking in Ladakh. So in Tamil Nadu, it will take 45 minutes or 1 hour. So that means, which means that you have more solar intensity at the direct sunlight. So simple example, a solar cooker we are taking and cooking in Ladakh area means it is less time it will take. Which means that you have a more solar irradiation in that particular area. So more solar radiation in Kashmir area. So that is the direct sunlight. Whereas in case of Tamil Nadu and all, diffuse sunlight is more. So which means not in all area, particularly because we have a lot of pollution in pollution here in Tamil Nadu and all over other states of India. Whereas in Kashmir, not like that. Even it is a cool area, particularly that area, Ladakh and Ladakh, we have a very good clear sunlight. So we'll get that. Albedo is the fraction of radiation that is reflected directly back into the space. That's what when the yellowish line of sight, when it falls into that one object, particularly the diffuse beam, it gets reflected. So the efficiency will be reduced in case of diffuse beam. Okay. And see here, sunshine hours. So this is the peak sunshine hours. The daily irradiation is commonly referred as a peak sunshine hours. So in India, we have 5 to 7 hours peak sunshine hours, which means that 5 to 7 sunshine hours, we will get a maximum peak of sunlight. So which means that maximum power we can produce for 5 to 6 hours daily, because solar power is available during the daytime only. So you can see in the graph, so 7 a.m. it slowly rises, but when you will get the peak, so you have at 10 o'clock and then the irradiation varies and you are getting the peak at around 12 o'clock, and till after 2 you have a very good solar irradiation, and after 2 only this gets reduced. So you can see this clearly here in this figure. So which means that you have 5 to 7 hours. You have a sunshine hours. So this is what the solar peak sun hours in India. I'm talking about India because India, India, you have a very good potential of solar. So this is different from one country to another country. If it is Algeria, that is different. If it is a New Zealand, that is different. If it is UK, that is different. But India is concerned a very good tropical region where we have a very good peak hour sunshine hours, peak sunshine hours. So we have a abundant of wind power, solar power. So this is what we learn from and how the solar power is producing. So today we have this PV panel. So from the PV panel, the solar radiation we are getting, so which is collected, and you have the positive and negative. So you have which is so when exposed to the light, so the potential difference, this voltage difference occurs between, and due to this light, the electrical flow is happens. So what happens here is, that's what I said, the energy from one form to another form. So this light energy is converted to the electrical energy in case of a solar. So light energy is converted to the electrical energy. So you can see this. So this is what happening in solar. So conversion of one form to the another form. Okay. Okay. So solar technologies. So you have a lot of solar. Not only that. I said here. So solar PV system and the solar hot water systems. So like a solar cooker is also there. So that and all for you in houses we can use that utility. This solar hot system you can see in most of the houses. You can see this the hot water system in the roof. You can see that one in the building, top of the building you can see. So that is solar hot water system. And the next one is what you have. This is CSP panel, concentrated solar panel. So this is a parabolic reflector where the solar energy is converted into solar thermal power. So solar thermal. So solar energy is converted to thermal energy. So this is another form. That's what solar light energy, heat energy, and then electrical energy. So this is solar power, CSP, concentrated solar power. Parabolic reflector you have, that's one. And this one is passive solar design. So you active solar and a passive solar. So this is directly in the houses and all we are getting the sunlight. So this is passive solar. And this is some of the applications of a solar off-grid rural application. You can see in the rural areas, the government of India and the state government are promoting this solar. So you can see this. So here you have this solar power. So in a farms, for particularly for the agricultural, to promote the agriculture, the schools, in schools, in the small houses and all, the rural side, you can see this even now. So a lot of projects are going tremendously. So this is off-grid solar application. And apart from that, you have like cell phones. You can see this cell phones charging with solar and latents in the so that, which means that the latents, you can see this latents in the park or so like that area. So this will be during the daytime, the solar energy we are getting, and through the battery backup in the night also this will be get illuminated. So during the night, so which means that there is no electric power from the electricity board. So which means from the battery itself we are getting the power, we are storing the power, and during the night hours, during the day hours we are getting the power, and during the night hours this is we are getting it is illuminating here. So you can see, and you have street lights. So you can see this, most of the street lights are solar power. In the traffic signals, you can see in many of the traffic signals now they are using the solar because solar is available. So I said that's 300 days we are getting, so almost. So that power is abundant, available throughout the day. So we can use this power here, and in cell phone towers. So all the communication towers and all, we can utilize this power. So this is solar. So this is off-grid. Off-grid means which is not connected to the grid. So this is called a off-grid. So for small applications, we can use for the household applications, for the commercial application also you can do. So household applications, small things. we can do this off-grid application. See, this is off-grid mobility application. This is different scenario. So you have a powered car, powered solar powered vehicles, solar powered auto. So these are all the technology, solar PV technology, off-grid mobility. Even in a desert also, in a camel, what they'll do is the solar panel they are using for medicine. The medicine is there. It's a medicine kit. Some medicine kit you have, it should be like a refrigerator. So with that solar power, they are refrigerating all those things. So it needs an electricity. So that and all they are doing with the camel, that animal from the at the above that camel. They are replacing, because in desert there is no how you will produce the power. So like this, different technologies going on. Keep on so tremendous change in the last decade particularly, so growing tremendously. So this is grid connected. So that is off grid. What I said is off grid, and this one is grid connected. So grid connected is in a house. If you say in a house, you can see in the house over the roof, it is called as a rooftop. So in the rooftop, the solar PV panels, so PV cells, so the light intensity, so sunlight intensity, which gets, and you have, it converts into the electric power. So you have this solar. So what power we are getting from the sunlight is, so this is your DC power. So this DC is converted to AC. So by means of an inverter, which is converted, and this supply, what happens is, which is given to the utility grid. So this is called as a utility grid. So we can consume the power as well as we can give it to the grid. So nowadays, this is called as a feed-in tariff. So feed-in. So feed-in means, so you can consume the power, and this is in the electrical bill adjustment. So this will be the remaining power we can give it to the grid, so that it will be adjusted in the electricity bill. So there's a saving of power in terms, in another way. What we call this as a prosumers. So what is prosumers? Consumer. So what is consumer? Consumer means, see, we are all in a house, we are consuming the power. So from the electricity board, we are consuming the power, we are utilizing everything for watching TV, for utilizing so iron box or a laptop. So we are doing many applications we are using, so day to day. So this is consumer. Now this is called prosumers, which means that you are a consumer as well as you are generating the power. You are consuming as well as you are generating, two way you are doing, which is called as prosumers. So that's what the rooftop grid, rooftop solar is called as a prosumers. You're a generator. You're like a not if you take a thermal power station, they are a very big generator, but you are a small generator. But generator is also, your contribution is also important. You are contributing, say for example, even a 1 kilowatt power, you are contributing to the electric grid. So you are a prosumer, you are a generator. You are a generator, which means that you are consuming as well as you are generating the power to the grid. So this is grid connected solar PV rooftop system. Clear? So this DC power is converted to AC power by means of inverter, and you are utilizing, and this AC power we are giving to the hidden to the electricity grid. Okay. So this is PV solar. Okay. And we have a lot of project schemes, like a chief minister solar power. You can see in houses in a rural side, we have houses group house is what we call. In that and all, the solar powered villages, solar powered houses are there in most of the villages. So that is Chief Minister Solar Power Greenhouse. So a lot of schemes are there in government. They are giving subsidy for this one. Solar, and another one is Solar Power Greenhouse scheme for weavers. The same thing as like a Chief Minister scheme. This is especially for the weavers. So to promote the weavers, okay, the power loom industries. So we are giving subsidy. Apart from that, the weavers are also very important. So these are all some of the schemes. And apart from that, we have a solar village in Irumbai village that is in Viluppuram. So fully, the village itself is totally powered by solar. So we are using, so the project is going on. And solar irrigation pumps to the farmers. So for the farmers to promote the agriculture, so this irrigation, for the irrigation pumps, the solar power irrigation pumps to the farmers. So this is solar project scheme. So some of these projects for solar. Okay, so you have this. So this is rooftop solar. So rooftop solar in railways, all industries, all railways or whatever. If you take any central government organization, you can see at the rooftop solar, you have a solar powered panel. So in railways, trains, local sheds, hospitals, in offices, everywhere the government is implementing, because we have a target of 175 gigawatt. So we are marching towards the target of 175 gigawatt in the sense. So we should have a lot of projects. So the government is promoting the solar power projects in all sectors. So this is one of thing railway. So this is a PV panel. This is and all. This project is PV panel. Next is solar thermal. So that's what earlier I said. CSP, concentrated solar panel. So you have a parabolic reflector. So you will get the power, and you can see this. So the solar power, you can see this PV panel. It's like a U-shaped, C-shaped panel. So you have a more intensity of solar will be reflected, and that is converted to thermal. See here, you have a solar field. So you have a exchanger. That means like a boiler. We have a steam generators, a boiler. So you have a small pipes of vessels. This vessels. So this gets heated. Like how in a thermal power station, this get pressurized and the temperature is also raised by means of this heat wave. Because of this heat wave from the sunlight, this pipes, the brown color, you can see this pipes and all. Through these pipes, we have a high temperature and high pressure. So you can see this generator, steam generator is called as a boiler. So this energy is steam energy, which gets converted into what? Electrical energy. So by means of the turbine. So the steam energy is admitted over here, and the work done is converted into this mechanical energy into the electrical energy. This is connected to the grid. So this is generators. So you got it. So, and here you have, what is that? This steam gets converted into water, which is called as condensation. So water gets converted to, so the steam is converted to water is called as condensation. So here you have a condenser, and again this water is injected here, and the same process will be here. Same process will be here. So you have this steam, the steam which is admitted here. So this is the water is gets converted to steam. It's called as an evaporation. So here the evaporation takes place. The water is converted to, so here the water is converted to steam. It is evaporation, and the steam is converted to water is called as a Okay, so this is 1 megawatt solar thermal power. So you can see this solar thermal power. So you can see this. This is in IIT, the setup here for 1 megawatt solar thermal. You can see the parabolic reflector. And this is another one. You have solar thermal power. So in the towers, the communication towers and all, we can use this operations. You can see this. So this is solar thermal, same what we explained earlier. So from the even this is one of the main advantage of this solar thermal is it's like a storage. That is the major advantage. So this is another figure. So you have a two storage, cold storage and the hot storage. The molten salt will be there. So during the daytime, through this heliostats, you have the solar power. The collector, so the receiver, the tower collector, which receives the power, and that hot air, we have a thermal storage. You have two molten salt, hot and cold. So this gets stored as like a battery. So even after the daytime also, you will get the power. So that is the main advantage of the solar power, solar thermal. But in India is concerned, this is very few. The solar thermal is very few, but in most of the countries, European countries and other abroad countries, we have abroad and all. We have this solar power, this solar thermal power is very high. Okay, so this is about solar. And next we'll move on to wind. So wind is very important here because in India we have abundant power. We have very good growth. So this is Tamil Nadu is concerned, and there are two predominant states which have a high wind power potential. And Tamil Nadu, we have a highest capacity. You can see this. We have a passes. We have a potential in these areas in Tirunelveli, in Kambam, Coimbatore, Kanyakumari. In these areas, we have a high wind power potential. Okay, high wind power potential. So there are two types of wind we have. One is horizontal axis, another one is vertical axis. So the horizontal axis is primarily of axial flow types, which is and requires control mechanism to take the account of variation in wind direction. Vertical axis can handle wind from all directions. So that is vertical axis. So we have two types. So you can see this vertical axis and horizontal axis. So you can see this two-bladed also in this one. In horizontal axis, you have a two-bladed turbines also, two-bladed wind turbines. So this is the wind turbines we have. And this is another types of wind turbine. So you have a vertical axis. You have a lot of this modeling still in Tirunelveli. Still in Tirunelveli, I have seen this. This is you can see the Savianus type, the older one, and Darius type. So this and all still is there. The model wind turbine is still there in Tamil Nadu itself. This one, and this one is horizontal axis turbine and vertical axis turbine. So most probably we have a sorry, horizontal axis turbine. So this vertical is Darius type. So you can see this Darius turbine. And what are the how the wind turbine rotates? So both wind or sun, the energy which is coming from the sunlight actually. So from the sunlight only we are getting the wind, and because this is only the cycles form during the sun, during the day, the sunlight which converts, you are getting the humidity. So wind is blowing because of this sun only. So you have wind power only because of this sun. So this is the parts. What are the parts of the wind turbine? So this is the blade, and this is rotor. This is pitch. Now there are two types of turbines actually: stall regulated machines and pitch regulated machines. So what a stall regulated is, the blade, the blade, it just doesn't have that moving position according to the wind. So which will be fixed. So whenever the wind comes, whenever the wind blows, it will rotate, and the wind turbine will rotate and give you power. Whereas in pitch regulator, according to the wind speed, this blade gets adjusted, and you are getting the we are getting the wind power. So this is the wind turbine, and these are the parts we have. So pitch, this is pitch, and the brake. You have mechanical brake, and you have a two shaft actually. This end. So which means the wind speed is slow, which is increased by means of this gearbox. So you have the gearbox which is increased here, and we are getting the maximum output of wind power, which converts to the electrical energy by means of this turbine. So electrical generator, you have, this is your electrical generator. So by means of this, but because of this gearbox only, the speed is, you have a low shaft and a high shaft. So this gearbox which increases your speed, and we are getting the maximum output because of this. And this is another very important thing: anemometer. You have the anemometer. So this gives your the height of the hub. So this is your hub, I said, which is located exactly into that. This is the height of the hub, and measures your wind speed. So anemometer, which measures your wind speed, and this 10th one is your wind vane. Wind vane is direction. So which direction mostly before installing the wind, which direction we have to place the wind turbine is very important. So based on the wind vane, which gives you direction, So wind vane is your wind direction. Okay. And this is your yaw control. 14 is your yaw control. The yaw control itself, like a fan, how it is rotating, like that it gets adjusted. So this is yaw control. So the tower, this is 15th is your tower. So this tower will be fixed, and this gets adjusted. So yaw. And here also you have a off-grid, isolated grid, and central grid. So for the small applications, we have a off-grid wind turbines. So this is for the battery charging, for the water pumping, all those things we have a off-grid wind power. So this is off-grid. And isolated grid. So 10 to 200 kilowatts. So it is isolated grid. It's a high or low penetration. So this is isolated grid, and this is central grid is 200 kilowatt to 2 megawatt. So this is what we are. Even now we have a 2.5 megawatt more than that. Also we have a wind generator. So this is connected to the grid, central grid. You have like a farms. So you have more number of wind turbines. And so we have two types of wind turbine, wind actually. One is onshore. Onshore means in the plains. That's what, in the terrains, in the complex terrains, like a mountains, in the hills. There also we have in India, we have in a complex terrains, like ridges or hills or mountains or in a plains. Everywhere we have a wind turbine. So this kind of wind turbine, what we call in the plains and all, it is called as a onshore wind turbine. And you can see this one is a offshore wind turbine. So offshore wind turbine in the sense the wind turbine is installed inside the sea, in the sea. So this is called as a offshore wind turbine. So this is what. So you can see another one. So you can see here. So the in this you have a sea. See this in the sea. You can see the wind turbines inside. So this is what is the advantage of onshore and offshore is in offshore you will get a high wind power. Why? Because in case of onshore, the capacity is, as I said earlier, so this is 200 to 2 megawatt or 2.5 megawatt. Yeah, even the technology comes free. But when you go for offshore, normally 8 megawatt or 10 megawatt, even up to 14 is there. So you have say that, which means that single machine, I'm talking about single machine is 2 megawatt in onshore. In offshore, you have a 10 megawatt or 14 megawatt means high power, high wind power you'll get. And the intensity also in the, and the, what you call wind power density. So wind power density is very important factor for the output of wind power. So this wind power intensity is very high in sea, particularly when compared to the plains. So that is the difference between your onshore and offshore. So in offshore, you have a high wind power density, so that you will get a more wind power. So the speed is also more, and the turbulence. So turbulence means uh, what is the vibration? So the vibration is also very less. So once in case of a sea, so whereas in case of a plains and all, you will get a more turbulence. So these are the some of the difference between onshore and offshore, which means that noise is less in case of offshore. So these are the some of the advantages, and the projects are already in foreign countries. In India, the project has started, slowly is going on. And this is another technology. This is another challenge also. It's a hybrid power. So you have a wind or a solar. So wind and solar. So this is a hybrid power by means of both. In this wind is available in the night or in during the morning hours, early morning, you will get the wind. And the solar we are getting during the daytime. So it is complementing nature. So this is another technology. So we are getting both the power so as to meet the demand. So integration of both will be mix match. This is called energy mix. So energy mix of wind and solar. So your this is hybrid power. So this is not only hybrid, is not only wind or solar. Anything, any combination. You can put like a diesel generator. See, when you're using a electricity power supply here, another supply from a solar. Suppose you are using a diesel power. So even using generator also in some of the we are using generator. Suppose the power is not there, we are using a generator in most of the commercial activity companies. So in the small commercial activity industries, or even in the small hospitals, labs and all, they are using, right. So it is also a hybrid, which means that that is a diesel generator, and normally state electricity board power we are getting. So this is also hybrid. Similarly, which means that the reliable, another redundancy of power supply we have to get. So this is we are getting in a house itself, in a, even in a in commercial buildings and all, we are getting same thing here also. For integration of a wind power and the integration of the power to the grid, wind and the solar in the same location, it will be very helpful to meet out the demand. So here you have a wind and solar. So this is called as a hybrid. I said hybrid is not only wind and solar, any combination of diesel generator or the latest technology, whatever kind of thing you can go. So a lot of technology is going on this hybrid, wave power and wind power, wind and hydropower. So a lot of technologies are going. So different kinds of hybrid powers going on. Going on this particular area. So as to meet the demand, that is the next thing. So integration is another challenge. So all these things are going on. And this in wind is concerned, is the informed power available only during the May and September as per Tamil Nadu and Gujarat is concerned. However, in Tamil Nadu, we have a few locations, Kanyakumari and all, we are getting the 9 months we are getting. So that is the thing. And extreme difficult in grid management. I said, no, this is a variable power. I already said that is an informed power. And meeting in the grid integration is little bit difficult. Okay. And a biopower. So biomass. So biomass is the organic material made from the plants or animals. So any waste product, any waste, particularly plant in the sense, say for example, the vegetable waste. For example, I will tell you the Coimbatore market. So every day tons and tons of vegetable waste. That vegetable waste are collected, and from that vegetable waste we are producing the power. So we have a 250 kilowatt biogas energy there in Coimbatore. So the waste every day, the tons of waste vegetables or waste vegetables. So that and all we are taking, and from that we are producing the powerless your biomass. And not only from the plants, animals also. Say any waste like poultry waste. Say for example, I'll give for example for animal waste, even a cow dung. The cow dung which crushed in the liquid form and inserting into it's like the biomass is like it's like a tank with closed tank. So you have the fermentation process will takes place, and from that the gas is produced. That gas in the rural areas you can use it as a for cooking. So for cooking you can use, and also this gas also you can convert into electricity. That is also possible. Sorry, but however, this gas conversion of gas into electricity mostly we are using as a directly as a gas. So from the organic material of plants and animals, we are getting the power as biomass. And not only that, poultry waste or from the wood chips. Okay, from the wood chips, from the wood chips, you know. So that waste also you can use it to utilize as a we can produce a power. So from mostly from the plants and animals. So this is the biomass plant. Biomass can be converted to other usable forms of energy like methane gas or transportation fuels like ethanol or a biodiesel. So I said earlier, from the Jatrapa seeds or from the Pungan seeds. So these seeds and all, because all seeds have that as nature what you have, that oil. So from that we can generate that oil, we can produce that oil. So this is biodiesel, biofuel. So this is a So, so biomass is different and bagasse is different. So you can see this. Okay. Hello. Okay. Hello. Hello, Bala. Hello.
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 Yes, yes, Bala. Yes, tell me, Bala.
Hello.
Yes, uh, we are hearing you. Yes, no issues. You can proceed. Guru. Yes, we are able to hear you.
Hello. Hello, Bala.
Yes, yes, Suresh.
Hello.
It's audible.
Yes.
What happened?
We'll continue.
Yes.
Bala.
Yes, you continue, but your screen has been disabled. We could not see your PPT.
Hello.
Yes, we could not see your PPT, Bala. Can you
Hello?
just share your? Yes, we are able to hear you. You just hello. Uh, you share your PPT, or else we'll go for questionnaire. So that will
Hello.
be okay then. Fine. Yes, we are able to hear you, Bala. Yes, we are able to hear you. Just go ahead and share your PPT. Yes, it's audible right away. அது தனிங்க சார். Guru?
Hello.
Yes, it's audible. You can proceed. Nothing to worry. You can share your PPT. Are you able to listen us?
Balagur sir,
Okay.
can you able to hear me, sir? Balagur sir,
Yes.
can you able to hear me, sir?
கத்துறோம் கதறோம் ஆனா ஆளை காணுமே. ஐயா கொஞ்சம் வாங்கய்யா லைன்ல.
Bala sir? Balaguru sir, can you able to hear us?
Yes. But he could not. He just give us yes or no, sir. So whether you are able to hear us or not. Okay, the time is running out. So if you can go ahead and have questionnaires, then we can close the session actually. Are you able to hear us? It's not audible. Okay, with that
I hope
we'll
he's not
close.
responding. There is some issues in the
Yes, I think so.
Yes.
Suresh sir, you can propose vote of thanks so that we'll have the next. The people can join the session, next session, so that would be fine. Because
that's thank you, Bala. Thank you for the opportunity. At the outset, like to thank Mr. Balaguru sir has given a very good insight about the presentation. I mean, regarding renewable energy sources. He has taken in two different ways, right? From the non-renewable to renewable. He has given the insight of the fundamentals of renewable and non-renewable. Why we want to move to renewable, and what are all the renewable energy scenario as far as in India, as far as in Tamil Nadu that we are looking for. Based on his own experience, he has shared a lot of things with the real-time data and everything. I hope this has been very good. This is one of the very good and best and excellent presentation. Even people those who doesn't know about the about fundamentals really can able to easily understand. In that way, he has given very slowly, very legibly, and very neatly with all relevant data. Thank you, Balaguru sir, for a wonderful presentation and excellent presentation given to us. It's really very helpful for the students, those who are going to do further projects. And of course, if any students is needed in doing kind of projects, you can feel free to contact Balaguru sir. He is very helpful, and he is very he will respond to each and every call, even at late hours, because I have a very good coordination with Balaguru sir. Thank you for the wonderful opportunity, and thank you for the presentation. I thank you all the listeners, those who are in the Zoom as well as in the live, those who have taken a good, remarkable knowledge from Balaguru sir. That's to which is going to be the renewable one, which is going to be a new one for the nearly future. Thank you, Anandal, for the those who are in the session, and I take the. I just hand over the session to Bala to conclude, and I will, if you want, you can close or anything else.
Yes. Thank you so much, Suresh. So all the people can join the DevOps, which is going to be the next part of the world, where it is going to be having a cloud connectivity, and the other sort of development is going on with dev operations. So it is a development plus operations, which is going to link with all such engineers. So I request all people to join the ID. So I have shared it in circuit as well as Ursago. So you can take up the ID and you can join. So welcome. And any other questions we will discuss by tomorrow, because we have 3 sessions actually by tomorrow. We'll just catch up them. Anyone having any questions? You can just open up, unmute yourself, and you can just say a few words. You have any questions, Ma?